This is episode 4 of There Just Has to Be a Better Way. This one is entitled Positive Close, No Flap, Bathroom Vent Hood. I live on top of a cliff overlooking a river valley, and this river is connected to a lake. And the problem that I have is wind. And when it blows, it comes across the lake, up the river, across the valley, and up the slope, and I get hit pretty hard. Now this is the bathroom fan that we chose to put in the outside wall of our bathroom. It's a Panasonic Whisper Wall 70 CFM. The model number is FV-08WQ1. Now normally you don't want to go through to an outside wall. You go up through the ceiling and out. Well, the way our bathroom is laid out, we couldn't do it. So we initially installed this unit, and the fan works great. It's quiet. You can hardly hear it running. But when the wind blows, the flapper flaps and lets in cold air. Not a good thing. So since that vent hood failed and we liked the motor, we decided to buy a custom-made vent hood that has a magnetic closure. And when we installed it, we thought our problem was solved. However, that wasn't the case with the first windstorm. And as you can see in this image, you can look straight through the fan grill and see the flapper is open and cold air is just rolling into the bathroom. And even when we weren't in the bathroom, you could hear that annoying flapper going bang bang all night long until the wind calmed down. So with that hood failing so bad, I decided to put the original Panasonic hood back on, and this time have the flap controlled by an arm run by a actuator. And this is the actuator we chose. It's a Belimo shutter motor, and we bought it from acfgreenhouses.com, and they use it for their greenhouse shutters. But with a modification to the arm, as you'll see, it controls the flapper very well, and no air can raise the flapper because it is solidly closed. Now you may question why we didn't use a HVAC duct damper. They do close, but the two big problems with them is wind can still push them open because there's a light spring on the flapper. And with the wind that we have, I was afraid it would open. And two, every one that I could find was 24 volt. This Belimo unit is 110. I wanted to stick with 110 instead of having a auxiliary 24 volt step down transformer. So to start this project, I bought a plank of the plastic trim like you can see at Lowe's or Home Depot. This is 10-inch wide. And I've got the 4 pieces cut, and then I drilled some pocket screw holes and then started pocket screwing the box together. Now what the box is going to do, it's going to set on the base that's on the outside of the house, and that will move the vent hood 10 inches out from the house, which will give me room to put the actuator. Now if you've ever used a pocket screw set, you'll notice that the square bit is very long so that you can reach into places. However, trying to build this box, it was impossible. The tool you need to make it possible is, as you can see, the DeWalt right angle attachment. It's an impact ready. Their part number is DWARA120. This little tool makes it possible to put the pocket screws into the box to finish it off. And you can see here just how we attached it to our impact, and we're able to drive the screws in with little trouble. And with the box completed, we set the Panasonic vent hood onto the outer wall of the box and screwed it in place temporarily so that we could test how we were going to set our actuator. And as you can see, the box is big enough we can put the actuator off to the side, and the arm aligns with the center of the Panasonic flap. So like I said earlier, with the arm that comes with the actuator, you have to modify it slightly. So you can see that we put it in a vise, pounded it down to make a 90-degree angle, and then bent it at about 30 degrees. And when you're done, this is roughly what it should look like. It doesn't have to be pretty, it just has to work. And then it was a simple matter to reattach the arm to the actuator, swing it into position, or mark the spot for the hole, drill it, and then bolt it from the other side. And then using a washer and a sheet metal screw, we screwed the actuator down to the box. To test this unit, we took a switch cube and a power cord from an old piece of electronics that we cut off, and then with a couple wire nuts we attached to the power cord of the actuator, and then plugged the switch cube into the wall and proceeded to test it. And with some adjustments to the length of the flap arm as well as the position of the flap arm on the actuator, we got it to open almost full. And then close to the point that the foam seal was compressed so that I would have an airtight seal. And then I removed that magnetic closure vent hood from our mount on the side of the house. And here's a view from our bathroom looking straight outside. I decided to use that vent hood's connecting 8-inch pipe. So I took a Dremel and a cutoff wheel and I went all the way around the pipe and cut it away. Then I installed my white plastic box on the side of the house using the pocket screws and some caulk to make it watertight. And importantly, I had to make sure that it was level so it didn't look crooked. I then reinstalled the connecting pipe and caulked the end of it so that I had a airtight and watertight seal. And then I reinstalled the Panasonic hood with 4 screws and some caulk to make sure that was watertight. As you can see, it does protrude 10 inches out from the house. However, given the propensity for the standard spring-loaded flappers to let cold air into the bathroom, I was tired of having a cold bathroom when the wind was blowing in the wintertime. I'll live with it. Now this shot is from the bathroom side looking through the box to the Panasonic flap. And here is a close-up shot of the inside of the box and the arm that is going to connect to the actuator. Then we installed the actuator and put the screw in to hold it in place, and then pulled on the arm to hold the flap closed tight against the foam, and then tightened it down to the actuator arm so I would have a good seal when the actuator was in the closed position. So then I hooked up my test rig again and ran it through a cycle to make sure that the flap would open far enough so there would not be an obstruction for the 70 CFM fan dumping moist air out of the bathroom. And it would close and seal correctly, because that was the whole idea of this science project. Next, I wired the actuator to the fan motor. When the fan motor comes on, the actuator would open. When the fan motor shuts off, the actuator would close. But if you look directly under the fan motor, you can see the silver tape where I taped down the actuator power lead so it would not get in the way of the fan blades. And then the final test was firing it from the fan controller on the wall. and it passed its test very well. You can barely hear it start. But you can hear it shut down, whining sound that it makes when it's closing. But again, you want to not have the whine and have cold air, or do you want the whine and be warm in the bathroom? I chose warm. And the last thing to do was put the plastic vent cover on that was color matched to the wall, and we're done. There'll be no more cold air coming into the bathroom when the wind is blowing hard. Well, I thought I had the cold air problem in the bathroom fixed. However, I missed something that I should have seen. If you notice, as we zoom in, that is daylight at the very top. Apparently, Panasonic was not very good with their foam seal, and we're going to have to get that fixed if we're going to truly have no air leaking into the bathroom. So in this next image, as you zoom in, you can see that I've got some extra foam tape at the very top. Now what we did is I bought this tape from Amazon. It's a 1/4 inch by 1/8, and it's 50-foot roll. I don't need 50 foot, but that's what it comes in. You get 3 rolls that are stuck together side by side, and this stuff works pretty well. The brand was Top Dure, Topdure, and it's $7.99 for the roll, so it's nothing really. But that thin, you can't buy it in the stores. So what I did was I cut a piece, opened the flap, and then stuck it backwards against the edge of the opening, and that created the seal at the top. Then I tested it again, and I thought I had it. However, there was 2 other areas where I had missed, and those had to get fixed. So that's what we're going to accomplish next. Now over on the left-hand side at about the 10 o'clock position, 10:30 position, you'll notice that dark area. That is another piece of that foam, because when they ran the vertical foam, it didn't touch the horizontal foam. There is a gap. Poor quality control on Panasonic's part. But anyway, I took the thin tape and I stuck 2 pieces together to give me the extra thickness that I needed, and stuck a little piece there. And then we move over to the other side, because the other side was just the same way. And I put 2 pieces together and stuck that in the corner. And finally, this shot is what I ended up with. And I truly now have no air coming in, but it has been a battle.